Okay, so now that we've seen we can convert quadratics back and forth from factored form to standard form to vertex form, and we've also seen that vertex form is really the easiest form for graphing, let's use something called completing the square to convert a quadratic from standard form to vertex form. Now I know y'all saw this in Algebra 2 last year, so this is a good refresher for those of you who saw it and didn't understand it or could just use a little reminder of how to do it. Okay, so what we're going to do to get started is we're going to get anything that contains an x, keep it by itself. So I'm going to go ahead and subtract at 8 over. And then I have 3x squared plus 6x. And I'm going to put a little blank here. And we'll talk about why we do that in a minute. All right, so I'm not really ready to complete the square. I'm just going to really focus on this side. But remember, in order to put this in factored form and sort of complete the square, I need that a value to be factored out. So I'm going to take it out, and then I have x squared plus 2x. And then we just have to do the little puzzle where we figure out, okay, well, what number is going to be my c value, right? This c value right here. And that's going to be based on whatever goes down here. So let's start by taking our binomial square, and that x squared plus 2x plus 1, and then let's just say, all right, I'm going to look at this value here, and I cut it in half. Half of 2 is 1. And then because this is x plus 1 squared, that means my last term is going to be 1 squared. 1 times 1 is 1. And then we're going to kind of work our way back up. So this 1 here is 1, but don't forget we factored that 3 out, so we need to take that into account here. And so in order to complete this square, we had to add 3 to the original expression so that we would have a perfect binomial square. We could factor it in this form. So we can't just randomly add 3 to one side of an equation without balancing it out. So I'm going to go ahead and put plus 3 over here. So now I've done the same thing to both sides of the equation. I'm going to just take this y minus 8 plus 3 and clean it up. That's y minus 5. And then to be in vertex form, let's just go ahead and add that 5 over. So y equals 3, parentheses x plus 1 squared plus 5. And then we're in business. We're in vertex form. You could graph that. You can see the vertex is negative 1, 5, and it has a vertical stretch of 3. I'm going to try and do the same thing here with b. You might want to pause and try this on your own, and then we'll come back together and give it a shot. You can kind of check your work, and if you got stuck anywhere, we can take a look together. Okay, so let's try this one again. I, again, am going to get anything that doesn't contain an x kind of out of the way. So I'm going to do y plus 6. And since I know I'm going to end up adding something, I'm going to go ahead and put a plus and a line. This is just kind of how I keep my life organized. You can do however you do. Okay, so what we have is negative 2x squared plus 8x. And I'm going to put that blank in because we're going to add something there so we can actually complete this square. And now I'm just going to work with the right side. Let's take out that negative 2. So then I have x squared minus 4x plus something. That makes sense so far. Now we can do the actual completing the square. And so I'm going to create this binomial here. And then once I figure out what number goes in the binomial, that's going to help me with everything else. So, of course, it starts with an x. And then because this is negative 4, I cut that in half, and I get negative 2. Then I think, all right, well, what's negative 2 squared? Because that's what's going to go right here. Negative 2 squared is positive 4. Good stuff. Now, that 4, remember, we factored out that negative 2, so we have to take into account that if we distribute that negative 2 back in, this becomes negative 8, right? This is from this right here. So we're actually adding negative 8 to complete this square. So I'm going to put a minus 8 here. All right, so let's just clean up the right side, and I have y minus 2 equals negative 2 x minus 2 squared. We're almost in vertex form. We just got to get y isolated. So negative 2 x minus 2 squared plus 2. And there we are in vertex form. All right, so now we're going to take a look at exploration 2.2.2, which is taking our standard form of a quadratic, ax squared plus bx plus c. We're going to prove that the method that we just did is really a general case of another, meaning we're going to complete the square so that we can solve the x. So our goal is a little bit different than putting it in vertex form. The goal here is to solve for x by completing the square. So you want to kind of keep in mind the steps that we took for completing the square when we're doing this. Now maybe you want to give this a try first before you watch the video on it, or you might want to pause it along the way and see if you get each step right. So kind of leave that up to you. So let's start by just writing our standard form or general form. Ax squared plus bx plus c equals 0. All right, so when we talked about completing the square, we could not have that process work if we have an a value other than 1. So what we're going to do here is we are going to divide by a. And so that leaves us with x squared plus b over a, that's our coefficient of x, plus c over a equals 0. Easy enough. All right, so remember we want to get our x's on one side of the equation, and anything that doesn't have an x needs to be on the other side. So I'm going to do x squared plus b over ax, and then I'm going to leave some space. I'm going to subtract that c over a here. And now we're really set up perfectly for completing the square. So you might want to pause the video here and see how far you can get. Otherwise, we'll press on. All right, so I am going to end up adding to both sides here. And so we're going to go ahead and take this quadratic, x squared plus b over ax plus something. We got to figure out what that third term is going to be. And then let's just take this b over a, and this is what gets the whole process started, remember? So we know it's going to be x plus, and then we're supposed to take half of b over a. So b over a times a half. That's going to get us b over 2a. I'm going to put b over 2a right here. That b over 2a helps us decide what we actually have to add right up here. It's going to be that number squared, b over 2a squared. And if we want to go ahead and kind of like FOIL or distribute that power, we would have b squared over 4a squared. Okay, so on the left side, we've got x plus b over 2a squared. And then on the right, we kind of want to work with these to get them together. So I'm going to go ahead and reorganize this. I've got b squared over 4a squared minus c over a. In order to combine these, we need them to have a common denominator. And 4a squared is our denominator for the first one. That means I need to multiply both of these times 4a, the numerator and denominator. Okay, so I've got b squared over 4a squared minus, and then I've got c times 4 times a, so that's 4ac. And then our denominator should be 4a squared. That's why we chose the 4a to multiply by. All right, so this should start looking kind of familiar. I'm just going to kind of keep working with the right side to clean this up. So I'm going to put them both over 4a squared. And then on top I have b squared minus 4ac. All right, good stuff. So now we're going to take this here. I'm going to bring down the x plus b over 2a squared. And let's keep in mind what our goal was. Our goal was to solve for x. So we're trying to get this x over here on the left all alone. So I'm going to go ahead and square root both sides. That leaves us with x plus b over 2a equals, and then remember, square rooting both sides to solve an equation gives us a positive and negative root. And then we're basically going to kind of square root these each separately, right? So b squared minus 4ac gets square rooted, and so does the 4a squared. Now the reason I call this out is because 4a squared actually has a square root. It's going to be 2a. The b squared minus 4ac is just going to stay under the radical. Okay, so we are almost done. We're still trying to solve for x, so the last thing we need to do is subtract the b over 2a. So then I have x equals negative b over 2a plus or minus square root of b squared minus 4ac over 2a. And then last but not least, we'll put these together into what you should recognize as your quadratic formula. Right, so negative b plus or minus square root b squared minus 4ac all over 2a. So just keep in mind that whenever you're using the quadratic formula, you're using a formula that was made by completing the square for any quadratic. And that's why it works for any quadratic, because it just follows the same process of completing the square. It just does all the work of solving for x ahead of time, and then you just plug in your a, b, and c values. Okay, so take a look at that. Make sure you feel comfortable with how each of those steps were done. And if you need to, rewatch the video.